Alex Floor here doing the Lab 7 home video report. It's March 1st, 2013, and this is a lab video for Physics 2211 M05. We will be finding the estimate of the mass of the black hole, and our assumptions are that the net force of a system is due solely to gravitational force of a black hole, and that we know the gravitational force is as listed. The data that we will be using and the information to calculate this is from the lab that we did last week. So we see here are our initial conditions, and this is what we will actually be plugging into VPython. So this is our VPython information, and here are the initial conditions plugged in, and all this information here is the way to calculate the different forces, both Fnet, Fnet perpendicular, and Fnet parallel. We also have a way to represent these on the Python output with arrows, where the first arrow, the blue one, is Fnet, the first one, the Fnet, is the black arrow, the second one, the Fnet parallel, is blue, and the third one, Fnet perpendicular, will be red. So we have this, and we have it set to output mass of the black hole. We also inputted different position data points from a file that was downloaded. So when we run the Python model, we see the gravitational force, and the force, the Fnet and the Fnet perpendicular, are pointing towards the black hole, which is this red dot, while the Fnet parallel of the star, which is the yellow dot, is perpendicular to both these forces. As you can see, when we output, the mass of the black hole is 2.52 e to the negative 31 kilograms. So this is our estimate for what the mass of the black hole would be on the star. So we want to know, what does this mean? And in the analysis, we showed the arrows provided in the programming visualized Fnet, Fnet perpendicular, and Fnet parallel, and we want to know, how do these relate to momentum and the parallel momentum and perpendicular change in momentum. So we know that since Fnet and the change in momentum are the same thing, we know that these quantities and the magnitude and direction of the arrows will also be in the magnitude and direction of the arrows shown. But Fnet and the change in momentum are not exactly the same thing. Force is an external cause, while momentum is an internal property of matter. And a force is required to change the momentum of any object. And the Fnet of an object can be defined as the change in momentum per unit time. But one of the main differences, we know that force is a time derivative of momentum. So they are related, but they are not necessarily the exact same thing. So we want to know, what if? So imagine the black hole whose mass you found was replaced by a black hole, but placed at the same location. So we assume that the motion of the observed star remains unchanged and is affected only by the gravitational force of the new black hole. Could you tell the difference? So if we know that the motion were unchanged, that would mean the mass of the black hole was exactly the same. So we assume that the star's mass is the same as stated, the position is the same as stated, and the gravitational constant observed, that they're all the same. So that means there's no other things that could change the Fnet, and since it would be exactly the same mass, that there would be no way to tell the difference. This is my video lab. Thank you.